Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about mean variance of a binomial distribution random variable example. The given example is the mean and variance of a binomial distribution are given by 6 and 2.4 respectively. Find probability of x greater than 2. So now coming to the solution. So given that the random variable x is binomial distributed random variable and its mean value is np and the variance is npq. So given that mean is np is equal to 6 and the variance npq is equal to 2.4. So now here np is equal to 6. Substitute here np is equal to 6. First calculate the q value. So q is equal to 2.4 divided by 6, which is equal to 0.4. Next, find out the p-value. But we know that the probability of the success plus probability of the failure is equal to 1. So from this equation, p is equal to 1 minus q. Now here the q is 0.6. Therefore, p is equal to 0.6. Therefore, substitute p-value and q-value into this equation. npq is equal to 2.4 equation. So n is equal to 2.4 divided by pq. Now here p is 0.6, q is equal to 0.4. So reducing this RHS term, we get n is equal to 10. So therefore n is equal to 10, p is equal to 0.6 and q is equal to 0.4. So let's find out the probability of p of x greater than 2. But we know that from the properties of the probability density function, p of x greater than 2 is 1 minus p of x less than or equal to 2. So, p of x less than or equal to 2 mean x is equal to 0 to 2. Using binomial expansion, sigma x is equal to 0 to 2 ncx into p power x into q power n minus x. Now here n is 10, p is 0.6, q is 0.4. Substitute all these values into this second term, we get 1 minus sigma x is equal to 0 to 2 10cx into 0.6 0.6 whole to the power of x 0.4 whole to the power of 10 minus x. Now here the second term substitute different x values. So that are x is equal to 0, x is equal to 1 and x is equal to 2. So that is equal p of x greater than 2 is equal to 1 minus first substitute x is equal to 0 10c 0 into 0.6 whole to the power of 0 0.4 whole to the power of 10 whole to the power of 10 minus 0. Next substitute x is equal to 1 plus 10c1 into 0.6 whole to the power of 1 0.6 whole to the power of 10 minus 1. Next substitute x is equal to 2 plus 10c2 into 0.6 whole square 0.4 whole to the power of 10 minus 2. And reducing RHS term 10c0 is 1 0.6 whole to the power of 0 is 1 10c1 0.6 into 0.4 whole to the power of 9 10c2 0.6 whole square 0.4 whole to the power of 8. Using this expression, find out the 10c0 10c1 10c2. So 10c0 is 1 1 into 0.4 whole to the power of 10. So 10c1 10 factorial by 10 minus 1 factorial into 1 factorial 0.6 into 0.4 whole to the power of 9 plus 10c2 is 10 factorial by 10 minus 2 factorial into 2 factorial into 0.6 whole square into 0.4 whole square. So now here 10 factorial divided by 9 factorial into 1. 10 factorial is written as 10 into 9 factorial. Numerator and denominator 9 factorial is cancelled and remaining term is 10. 10 into 0.6 into 0.9 whole to the power of 9. Here 10 factorial divided by 8 factorial into 2 factorial. The numerator term 10 factorial is written as 10 into 9 into 8 factorial and numerator and denominator 8 factorial is cancelled. The remaining term is 10 into 9 by 2 into 0.6 whole square into 0.4 whole to the power of 8. So now reducing this within the bracket term, we get that value is 0.012. So 1 minus 0.012 is 0.9878. So this is the probability value, probability of x greater than 2.